Hi students, good morning to all of you, right? Yesterday we studied about RMS value of AC current. What is RMS value? Root mean square value of AC current, right? Actually, AC current is measured in terms of heat produced, right? Heat produced in a conductor when AC current pass through it, right? And actually, we cannot measure AC current using DC meters, because DC meters works on the principle of magnetic effect of electric current, while AC meters works on the principle of heating effect of electric current, right? Sometimes AC meters are also called hot wire meter. It is called hot wire meter. So AC meters are called what? Hot wire meter. Why it is called hot wire meter? Because AC meters, AC measuring instruments make use of heating effect of electric current. But DC meters works on the principle of magnetic effect of electric current. So we have seen yesterday that EV is equal to E0 by 2. EV is equal to E0 by 2. IV is equal to I0, sorry, EV is equal to E0 by root 2. And IV is equal to I0 by root 2. We have seen, right? Here on the board, I have written a question. You please go through this question and read it. An AC voltmeter records 50 volt when connected across the terminals of a sinusoidal power source with the frequency 50 hertz. Write down the equations of instantaneous voltage provided by the source. So we have to write an equation in the form of I is equal to I0 sin omega t or E is equal to E0 sin omega t. We have to write. That's all. So in the question itself, it is given that the voltmeter shows what value of voltage, that is equal to 50 voltage. In an AC circuit, voltmeter always show RMS value. Remember that. Ammeter will show what you call RMS value of current. Voltmeter will show RMS value of voltage. Right. So without any fear, we can write what EV is equal to. EV is equal to what is called 50 volt, we can write. Understood? So in an AC circuit, voltmeter always shows the RMS value of voltage, and ammeter always shows the RMS value of current. That's all. Then what we can do, E0, but E0, we know that E0 is equal to root 2 into EV. Root 2 into EV, we can write. EV is given to you, that is equal to root 2 into 50. That is 50 root 2. 50 root 2 you will write. 50 root 2 is equal to 70.7 volt you will write. 70.7 volt we can write. So this is to make you know the conditions. What an AC voltmeter show? Usually AC voltmeter always shows what you call the RMS value of voltage, and the ammeter shows RMS value of current. That also done. Now we have to write omega here. Omega is equal to 2 pi f. Omega is 2 pi f means that is equal to 2 pi into what is f? F is 50 hertz. That is again 50. That is 100 pi we can write. It's a very simple problem to make you understand the terms. That's all, right? That is equal to 314. That is equal to 314. Now apply the relation instantaneous voltage E is equal to E0 sin omega t. Right? E0 is equal to 70.7 into sine 70.7 into sine 314 t you will write. This is the answer to the question. So numerous questions also we have to do. Then only you will understand the actual actual theory. To understand the theory, you have to do, to understand the basic of physics, you have to do many problems after learning the basic topics. Next, I am coming to AC circuits. Before coming to AC circuits, one term I have to clear you. That is what is called phasor. Today, I will explain you what is a phasor. So, to deal with alternating quantities, we need a physical quantity called a phasor. What is a phasor? That is a question. So it is an imaginary line. It is an imaginary line which is rotating in the anti-clockwise direction with respect to a fixed point. And this line has a definite length and it has a definite value of angular frequency or angular velocity. So phasor is an imaginary straight line having a definite length that is rotating in the anti-clockwise direction. This is called phasor. So theoretically, the length of the straight line is the peak value, the maximum values of current and voltage. What is maximum value of current? That is I0. What is maximum value of voltage? That is E0, right? So it is, but in practically, the value of the length is taken as the virtual values of current and EMF, EV and IV. But actually, theoretically, it is said that the length of the straight line must be equal to the maximum value. Maximum means amplitude of current and voltage. So remember that it is only a straight line of having a definite length that rotates in the anti-clockwise direction. Because this word phasor is very important for dealing with the alternating quantities, because you know the fact that alternating quantity can be represented by an equation I is equal to I0 sin omega t or E is equal to E0 sin omega t. Suppose current in an AC circuit is given by any instant is given by I is equal to I0 sin omega t. And also the current, the AC current can be represented by a graphical way of graphical method also. So to represent the AC current or AC voltage, we have a formula I is equal to I0 sin omega t and also a what is called a sinusoidal curve, right? So the expression I is equal to I0 sin omega t gives us the value of the current or EMF at any instant of time. But this equation does not tell us what is the clear picture which is happening in the circuit. But another thing is that when we represent the AC current in terms of a graph tells you that what is happening in the circuit, when the current is minimum, when the current is maximum, at which time, what is the value of current, everything, the clear picture we are getting when we look at the graphical representation of AC current or AC voltage, AC EMF. But it is very difficult to draw the graph of E is equal to E0 sin omega t or I is equal to I0 sin omega t. To draw the graph, we need infinite number of instantaneous values of current and EMF. Then only that can be drawn, right? So an AC current can be either represented by an equation or can be represented by a graph. But the equation will give you the value of instantaneous value of current or EMF at any instant, but that does not give you the clear picture of what is happening in the circuit. The graphical representation surely gives what is happening in the circuit, and but it is very, very difficult to draw that curve. These two difficulties have been overcome by the use of this physical quantity called phasor. There must be phasors separately for current and EMF. That means the current and voltage, there must be separate separate phasors. So, what is a phasor is actually moving in a circle. The tip of the phasor is moving in a circle, right? So I am drawing a circle here. Phasor I am going to here, right? This is the situation. A circle is made, right? So this I am drawing about only for current phasor I am drawing about. Okay. So the initial position of this is this position is initial. This is the initial position, right? So the horizontal length, this with an arrowhead, this is the phasor. The length of the phasor is equal to I0. It moves in the anti-clockwise direction with a constant angular frequency omega radians per second. Am I correct? When the phasor moves in the anti-clockwise direction, just like last year we have seen how the circle of reference and simple harmonic motion, how we have studied. The same way this is also. This also same. Right? Okay. So this I'm drawing here, right? So let me draw the diagram broadly at another position. This is the right. A small circle I'm making like this. Okay. This is the condition. Okay. Right. So now, right, this is the vertical diameter of the circular path in which this uh, what is called phaser is rotating with a constant angular velocity omega, right? Okay. So when this phaser is rotating in the anti-closed direction, the projection of this phaser is obtained on the vertical diameter. This is vertical and this is horizontal. That projection will give you the clear picture of what is happening in the circuit. Okay, suppose that, and also at the very same time we can calculate the value of current, right? Suppose the phaser rotates at any instant. This is the position of the phaser. What phaser it is? Current phaser, right? And this is equal to I0. Okay, and this is suppose this is O and this is A, and what is the projection of that? That is equal to OM. We can take. Suppose this angle is equal to theta, then naturally this angle also will be equal to theta, right? The phaser is rotating with an angular velocity omega, but omega is equal to theta into t also we can write. OM is equal to, now OM we can calculate. OM by this, suppose this is OP, right? That so this is theta means OM is the perpendicular side. OM by OP is equal to sine theta, we can write. Therefore, OM is equal to OP sine theta also we can write. But what is OP? OP is equal to I0 sine theta we can write. What is OM? That means suppose that the phaser is in this position initially. That means this is the position of, that means no, the instantaneous current is equal to 0. T is equal to 0. I instantaneous current I also equal to 0. As the phaser goes up, then what happens? This curve goes like this up to this. What is the value of this? Is at any instant t. This is what is called I. So this is I. OM is equal to I. We are calculating. At any instant, I can be calculated from the phaser rotation. Any instant t, the phaser, the position of the phaser is OP. At that instant, the current is equal to OM. That is equal to any instant current. Okay. When the phaser comes to this point, what happens, sir? This point means it is coming like this. That means the current becomes maximum. Current becomes maximum. That is equal to I0. That is equal to total current is equal to the whole length will come here. That is equal to I0 also can be calculated. When it goes out, that means on the other side, then this P will up. Then the projection will come down, down, down. And when it comes to this point, this one, again, when it comes to this point, this one, here it is. So you will get a sine curve as shown in the figure, right? That means by the rotation of the phaser, the projection is taken on the, actually this diameter is this only. What is happening in the diameter? The current goes on increasing to become maximum, and the current goes to minimum to 0. Again, that goes in the negative direction. When it comes to this point, the negative maximum, right? So by the rotation of the phaser, what we can calculate, we can see what is happening in the circuit. At what time, what is the value of current, that also can be calculated. At what time the current is maximum, at what time the current is minimum, and at any instant, what is the value of current? In everything can be calculated using a phaser, rotation of the phaser. So phaser, this is the importance of a phaser. Using phaser, we can know what is happening in the circuit. At any instant, the amount of current and voltage can be calculated. Here we have seen only about the current phaser. That can be used with the voltage phaser also, right? So we are very much concerned about this term, because to deal with the alternating quantities, the role of the phaser is very high, right? Because when an AC EMF is applied in a circuit, in an AC circuit, the resulting current is also AC only, and will have the same frequency. Current and voltage will have the same frequency. But sometimes, due to the presence of different circuit elements, the phase will not be same. Phase will not be same means the current will be minimum, that time the voltage will be maximum. That means there is a phase difference between current and voltage in AC circuits. That is only because of the variation, the variety of or the difference in circuit elements used. When the circuit element can be resistance, circuit element can be capacitor, circuit element can be inductor. Inductor means solenoid only. Okay, inductor can be there, capacitor can be there, resistance is there, right? If the circuit is a pure resistance circuit, then current and EMF will go together. That means current and EMF will be in the same phase. It means when current is zero, when EMF is zero, current is also zero. When EMF is maximum, current is also maximum. Again, when current becomes equal to zero, EMF also becomes zero, right? So current and EMF both are marked here. So suppose that this is the EMF curve. This is the EMF curve. So what is happening? When current is equal to zero, EMF is also zero. When current becomes maximum, okay. When current becomes maximum, EMF also becomes maximum. In this case, we can say that the current and EMF are in the same phase, but it will not take place every time. This would not happen every time. So this happens only in one case. Which case? In pure resistance circuit, what it calls AC circuit, the current and EMF will be the same phase. But when we have other elements also in the circuit, sometimes the current will go ahead the EMF by an angle, what is called phase angle. That can happen because of the different elements present in the circuit. Just like inductor, capacitor, etc. For example, an inductor is taken. I am drawing a circuit here. This is a pure inductor circuit. A pure inductor circuit which is connected to a AC EMF is equal to E0 sin omega t. AC current is that current whose magnitude is changing with the time. When current through inductor changes with the time, induced EMF is produced, hence an induced current is created that will oppose the main current. So through the inductor, the current to increase, current to progress, to increase, that will take. So for the current to become maximum, it will take some time, right? Voltage is applied, okay. Voltage has already applied, but when current passes through that, the induced EMF created inside the coil will oppose the very cause of production of the EMF, induced EMF in the coil. The very cause of production of the induced EMF in the coil is the variation of current through that. The current will be what is called opposed by the induced EMF created inside the coil. So what happens? The current increases gradually and becomes maximum. Already the voltage has gone, but the current which is passing to the coil is not progressing, not increasing to the maximum very soon. We can say that the current is lagging behind the EMF by an angle. That angle is called a phase angle. You suppose that the EMF applied is equal to E0 sin omega t, then current can be said as equal to I0 sin omega t minus phi. My omega t minus phi, where phi is the phase angle between or phase difference between the current and EMF. So in this case, we can say that E is equal to E0 sin omega t and I is equal to I0 sin omega t minus phi. So literally what we will say, in this case, the current is lagging behind the EMF by an angle phi. The same thing can be applied in the other case also, other way also. See, suppose I say I want to write I is equal to I0 sin omega t only. Then what we can write? You will write E is equal to E0 sin omega t plus phi. That means the EMF is ahead the current by an angle phi. Or we can say that the current is lagging behind the EMF by an angle phi. Either E is equal to E0 sin omega t and I is equal to I0 sin omega t minus phi. Or you write I is equal to I0 sin omega t and E is equal to E0 sin omega t plus phi. Both are same. So this kind of lagging behind and going ahead will happen in AC circuit in many situations. This is due to the presence of special kinds of circuit elements like what is called inductor, capacitor, etc. For example, suppose this is a pure capacitor circuit. I will teach that also, right? In a pure capacitor circuit, when an EMF is equal to E0 sin omega is applied, what happens is that the current leads the EMF by an angle pi by 2. Sorry, EMF by an angle pi by 2. Pi by 2 means that is what is called a phase angle by an angle phi. So we can say that if EMF E is equal to E0 sin omega t, then I is equal to I0 sin omega t plus phi. Plus phi. What is phi? Phi is the phase angle. So in AC circuit, this kind of things can take place. That means sometimes the current will be ahead of the EMF by a certain angle, and sometimes the current will be behind the EMF by a certain angle. This kind of phase difference can take place in AC circuits. So when in an AC voltage is applied, the resulting current is also AC and also will have the same frequency, but it is not necessary that always the current and EMF are the same phase. Sometimes the current can go ahead the EMF by an angle phi, and sometimes the current can go behind the EMF by an angle phi. This phi is called phase difference, right? So to deal with the two alternating quantities simultaneously acting in a circuit, we need the help of a physical quantity. That physical quantity, the name of the physical quantity is called phasor. When you go with the topic, then it will be easy to understand things. So this is about phasor. Am I correct? Okay. Now I am coming to AC circuits. But I say AC circuit is a closed circuit through which an AC current is flowing. AC circuit. AC circuit is a closed circuit, through which an AC current is passing is called an AC circuit. The first basic AC circuit is pure ohmic circuit. So we are actually applying how we can make use of phasors. That only I am doing just now. Okay. So this is a pure ohmic circuit. Pure ohmic circuit means an AC circuit containing what is called a pure resistance. This is positive, this is negative. This is instantaneous current. Instantaneous current. In the first half cycle of the AC, current flows in one direction. Next half cycle, this becomes positive and this becomes negative. And the current flows in the opposite direction. So the EMF applied we can write E is equal to E0 sin omega t. I can write. Okay. So the applied EMF, the applied EMF is equal to applied EMF is equal to E0 sin omega t. Right? Okay. This is the EMF applied. So you see an AC circuit, a closed circuit, closed AC circuit, and through which a current is passing as shown in the, this is called a AC circuit. Right? A closed circuit followed by AC current is called AC circuit. So this is a closed circuit followed by AC current, and through which an AC current is flowing is called AC circuit. What this AC circuit is? Ohmic circuit, is pure resistance circuit. What's the applied EMF? E is equal to E0. Instantaneous EMF applied is given by E is equal to E0 sin omega t. Next, you will write applied EMF written. Then resistance is equal to capital R. Resistance is equal to capital R. Therefore, instantaneous current I is equal to E by R. We can write. But E is equal to what? E0 sin omega t. So we can write this as equal to E0 sin omega t divided by R. We can write. Very simple, very simple. How I am applying a phasor, that also you will know it. Without use of the phasor, we cannot go with this lesson. That is a phasor. I have already made you understand that. This is equal to E0 by R into sin omega t also we can write. This is I. But you know the fact that when sin omega t becomes maximum, I becomes equal to I0. So what we can write? I0 is equal to E0 divided by R. Right? Because peak value of current is I0. When is peak value of current? Because current instantaneous value of AC current is controlled by what's a sign ratio, sign value. That is depending on the sign of the angle, sign theta or sign omega t. When sign omega t becomes maximum, then current becomes maximum is called amplitude of the AC current. In this case, amplitude of the AC current is equal to E0 by R. Hence, what we can write, I is equal in the solution, we will put in place of E0 by R, we can put I0. That is, I is equal to I0 sine omega t, I can write. What's the applied EMF? E is equal to E0 sine omega t. What is the resulting current? I is equal to I0 sine omega t. There is no phi appearing in this case. Right? Applied EMF is sine omega t. This also sine omega t. Not sine omega t minus phi or plus phi. Right? Here also there is no minus phi, no plus phi. Therefore, what we can say, the current and the EMF are in the same phase. So when in a closed AC circuit followed by AC current, that is having a resistance, a pure resistance, then current and the EMF are in the same phase. Current and EMF are in the same phase. What's the meaning of that? The meaning is this one. Suppose this is the EMF phase. So the EMF curve, and this is the current curve. Right? This is E oblique I. This is C, and this is omega. Omega means theta. Omega means theta only. Am I correct? So when T is equal to 0, theta is equal to 0, EMF is equal to 0, current is also 0. Right? When T is equal to capital T by 4, or theta is equal to 90 degree, sin theta is equal to sin 90, that is equal to maximum. That means current and EMF both becomes maximum together. It means current and EMF are in the same phase. Understand? When becomes equal to 180, sin 180 is equal to 0. This is sin 270 is equal to minus 1. The current and EMF both goes in the negative sense and becomes equal to 0 when theta is equal to 360 degree or T is equal to 4T by 4. 4T by 4 is equal to 4 cancel is equal to T. So this is the condition comes in the case of a pure resistance circuit. Pure resistance circuit is also called as ohmic circuit. So in the case of an ohmic circuit, the current and the EMF are in the same phase. So how the phasor diagram can be made? So phasor diagram is when the current and EMF are in the same phase. Knowing the idea, what is the idea? But we have seen that current and EMF are the same phase. How we have seen that? Because we know that applied EMF is equal to 0 sin omega. The resulting current we have calculated as equal to I is equal to I0 sin omega. So from these two conditions, we understood the fact that current and EMF are the same phase. Understand? Knowing this condition, you can draw phasor diagram also. Phasor diagram, so practically phasor diagram is made with IV and EV, not I0 and E0. But theoretically, it is said as that the length must be taken as I0. But in practical purposes, we take this is IV. Then what is EV? EV is equal to like this. So EV will be always more than big more. This is EV. EV and IV are parallel, therefore phi is equal to 0. This can be said like this also. Suppose this is IV and this is EV. This is EV, right? Theta is equal to, phi is equal to 0, we can write. That means the current and EMF. This is the current phasor IV. Current phasor IV, and this is the voltage for EV. Both are in the same phase. Further, the same phase means they are parallel to the current phasor and the voltage phasor. Both are moving in the same way. Suppose this is the current phasor. This is the current phasor moving like this, and this is the voltage phasor. Voltage phasor means this is the voltage phasor, right? So both are starting its motion from the same origin. So both are moving together. Then you will get a curve like this. So for smaller one, this smaller curve with the amplitude is smaller. The bigger one, this bigger amplitude curve. Bigger amplitude curve is for what is called voltage phasor, and the other one is this is the smaller amplitude one is current. So both these can be drawn with the help of these two phasors. One is current phasor and other is the voltage phasor. Knowing the idea that the current and EMF are on the same phase, we can write the phasor diagram. For pure ohmic circuit, this is the phasor diagram. IV and EV are parallel, are in the same direction, means they are in the same phasor. So you will write phi is equal to 0. This is the application of a phasor. And one important what is called AC circuit also has been discussed. What is that? AC circuit containing pure resistance, right? A circuit followed by a closed circuit followed by AC current is called AC circuit. This explained very well how phasor is applied to understand things, to know about what is the phase difference between current and EMF. So current and EMF in this case is going to be equal to 0. Tomorrow I will come with another topic related to AC circuit. Till then, bye bye. Thank you very much.